So now I'm starting to the new. Hmm, what happened? Okay, sorry. Infinite series. This is a new topic sequence we have done. So now, what is infinite series? Suppose an, let an be any sequence, okay, real number sequence. Then, if you take this n is equal to 1 to infinity an, this is a, if you take a1 plus a2 plus a2 up to infinite, is called infinite series. So this is simple. If an is a sequence, you take the sum of all the term, then that if you write in this way summation n is equal to 1 to infinity n, then this is called the infinite series. There is one more terms Sn. Sn. प्रांजल प्रांजल आपने आउटसाइड LNMIT से लॉगिन करा है, मैंने परमिट कर दिया, पर नेक्स्ट टाइम आई विल नॉट परमिट लॉगिन थ्रू दी LNMIT ID. This is Sn. If you take Sn is the take the sum of the first n term plus an. So that is Sn. What will be Sn minus 1? A1, A2 plus A2 plus A3, An minus 1. So that will be, it means S1 is A1, S2 is A1 plus A2, S3 is A1 plus A2 plus A3. This is called, the nth partial sum. Nth partial sum of the series summation n is equal to 1 to infinity an. Okay. Now, in this topic in finite series, again our main aim is to check whether a given series is convergence, divergence, or oscillated finite. Main purpose is same as in sequence. So I am going to tell you the first simple way how you can check the convergence or divergence of a series by using this nth partial sum. So convergence, divergence, or oscillatory series. So first is I'm giving definition from Sn. How you can check the convergence of a series from Sn. So you have Sn if Sn tends to a finite unique number, a finite unique number as n is tend to infinity, or you can write limit n is tend to infinity Sn is equal to S. Then series, this series n is equal to 1 to infinity an converges, is said to be convergent and Vatsal, mute your mic. Vatsal Prakash Mehta. And converges to this number S. So if limit n is tend to infinity, Sn is equal to S, or Sn converges to a finite unique number, then this series is said to be convergent, and it converges to S. Second point, if Sn tends to plus minus infinity as n is tend to infinity, or limit n is tend to infinity plus minus, sorry, Sn, this is plus minus infinity, then this series an is said to be divergent and diverges to plus minus infinity. Then this an, sorry, this is not a sequence, be careful, this is not a, we are talking about this series an is divergent and diverges to plus minus infinity, whatever with it. Third point, if there may be another, if Sn, this Sn does not converge, not tends to a finite unique number, a finite unique number as n is tend to infinity. It sometimes it is coming A, sometimes it is coming B. That's a minus 1 ki power, and if you take this series, then this series n is equal to 1 to infinity an is said to be oscillatory series. One more point I want to tell you, all the tests which I told you on this sequence cannot be applied into the infinite series, and all the tests which I shall tell you on the infinite series cannot be applied on the sequence. तो ऐसा नहीं है कि आप सीक्वेंस का इसमें मिक्स कर दें और इसका इसमें.
सर
ओके, नाउ एग्जाम्पल.
सर सेकंड थर्ड पॉइंट क्लियर नहीं हुआ सर.
Second, third, it is saying, suppose Sn you have a series. This is approaching plus minus infinity as n is tend to infinity. Then it is said to be non-convergent. Non-convergent means divergent. और डाइवर्जेस करेगी आइदर प्लस इन्फिनिटी और माइनस इन्फिनिटी, वो जो भी वैल्यू होगी Sn की. और इफ Sn डज नॉट टेंड टू ए फाइनाइट नंबर, अगर it is not giving a finite number, it is suppose minus 1 की power n. If you take, yeah, there is some expression. Sometimes it is coming minus, sometimes it is coming plus, yeah. Sometimes it is coming A, sometimes it is coming B, sometimes it is coming C. Not a unique number. Limit n is 10 to infinity Sn. Then this is said to be oscillatory. मतलब it oscillate. कभी इधर कभी इधर.
Sir, in second case also, Sn is not tending to a finite number.
Yes. So if I am writing plus minus infinity, it is the meaning of this. It is
So
not
then,
coming to
second case also, oscillatory series will come.
This oscillatory series, I told you, it is a type of divergent. Okay, you can say non-convergent. But if question is asked and you are saying non-convergent, and teacher was asking the particular type of series, so he will actually can cut half marks because it is a particular type series, so you can mention.
Sir,
I can give you example. Just wait. आपने मैंगो खाया है सबने? तो अगर आप किसी भी मैंगो को देखेंगे तो आप कहोगे दिस इज ए मैंगो, लेकिन अगर पर्टिकुलर टाइप आप मैंगो में जाओगे तो आप क्या कहोगे? ये लंगड़ा है, ये आबूनासी मैंगो है, दिस इज सफेदा. तो दिस इज वैरायटी ऑफ डाइवर्जेंस सीक्वेंस. This is non-convergent, but if we get some conclusion that this is oscillate minus 1 plus or any other thing, then you can say it oscillates. तो आपको जितना नॉलेज है उतना दोगे ना नॉलेज. That's why oscillatory series I am saying. Okay, जन्मेजे राठौर साहब.
sir, what is the difference between sequence and series?
Sequence is an. If you take all the terms as a summation, it becomes the series.
Okay, sir.
Any other? Sir, Divya, sir, it likes integration of sin x from 0 to infinity? No. I am doing question, then it will be more clear. Any other doubt? Okay. First example is you have a series summation n is equal to 1 to infinity log n plus 1 over n. This is a series. You can write like that. Question is it converges? Converges or diverges? So how you can do? An is equal to log n plus 1 over n. So far I know only Sn. So what is an? An is equal to, you can write log n plus 1 over n, or if you split, so you can write log n plus 1 minus log n. So what is your Sn? A1 plus A2 plus up to plus An. So here log n plus 1. So what will be Sn? This will be log 2 minus log 1 plus A2. Put n is equal to 2. Log 3 minus log 2 plus this will be A3. So this will be log 4 minus log 3 plus log n plus 1 minus log n. So here you can see these are cancelled out. Log 2 will be cancelled out here. Log 3 is here. So log n will be cancelled out. So this Sn will be log n plus 1 minus log 1. Log 1 is 0. So this log n plus 1. So Sn is equal to log n plus 1. Take limit Sn. So this is infinity. So here limit n is turned to Sn infinity. So you can say, so series, whatever series is given, n is equal to 1 to infinity log n plus 1 over n, not convergent, or because we know if it is infinity, so you can say is divergent and diverges to plus infinity. So in this way you can check whether a given sequence is convergent or divergent. I am taking one more example. Suppose you have a series n is
Sir, in
equal
the
to
example one, we also have to check the series is oscillatory or not.
yes, correct. Check it. Oscillatory series होगी तो आपको जब आप when you solve the problem, immediately you will get an idea. ये oscillatory है नहीं, it is directly converges to infinity. Sorry, it limit n is tend to infinity, Sn is equal to infinity. If it becomes oscillatory, so after here, you will get some idea. I will tell you how.
सर एक
Okay.
डाउट था.
बताइए. I will give an example of oscillatory series. Just wait, then it will be clear.
नहीं सर, बस ये पूछना था कि ऑसिलेटरी सीरीज कन्वर्जेंट डाइवर्जेंट दोनों भी हो सकता है ना, मतलब दोनों टाइप के हो सकते हैं ना.
Convergence कैसे होगा?
सर अगर
Convergence means it converges to a point. It cannot.
तो मतलब व्हाट इफ द सीरीज
whatever you
कन्वर्जेस
value
टू
of n.
जीरो बट वो ऑसिलेटरी है.
कौन सी है बताओ?
सर मतलब अगर मैंने पेंडुलम
अगर
टाइप
नहीं, give the
सीरीज,
example.
सर
There
तो
doesn't
ऐसा हो रहा है.
any
हाँ, तो
series.
so it
Yes.
is going from -1 to 0.5 to -0.25 to 0.125 to -0.125 का half. तो वैसा will converge to 0, but it is a converging
लेकिन
oscillatory
चैट बॉक्स पे
series.
लिखना जरा इसे चैट बॉक्स पे लिखो सीरीज, देन आई विल एक्सप्लेन.
हाँ सर.
राइट ऑन द चैट बॉक्स.
Sir, it can be -1 to the power n upon n, which he is explaining.
माइनस
-1 to the power n upon n,
यस.
whole upon n.
हाँ,
सर ऐसा
Sir, which
सीरीज
is
हो.
trying to.
एसएन पहले फाइंड आउट करो इसका. फाइंड आउट एसएन.
सर इसका एसएन तो लिमिटेड होगा.
हाँ, तो
इंफिनिटी
उसको
तो
फाइंड आउट करके आप डोंट मिक्स द सीक्वेंस एंड सीरीज. आप एसएन फाइंड आउट करो, देन फाइंड द वैल्यू.
नहीं सर, मैं बस पूछ रहा हूँ आपको. आप ये सीरीज अगर देखोगे जो मैंने चार्ट पे लिखा है.
और वन मोर थिंग, दिस इज डिफरेंट टाइप ऑफ सीरीज. I want to write one more thing. So far, I am dealing this series of positive terms. Here I am checking this A1. You can write here. These all are we are doing for positive terms, and you are telling me -1 की power n over n. This is a particular type series. This is known as alternative series. I will do this type of series, and the convergence of this type of series in which terms are alternatively negative or positive is solved by Leibniz test. I will tell you the Leibniz
Okay,
test.
sir. Okay, sir.
Okay? So just
Acha.
wait, one by one I am going. If I tell you directly, then you will create.
So, sir, I thought even this is oscillatory series.
minus 0.125.
हाँ.
आरुष इसका
ये तो
जनरल टर्म बताइए मुझे.
So,
अच्छा वो
तो minus half की power n.
This is-
Minus half की power n.
आरुष, this is
हाँ, sir.
alternative series.
हाँ
Alternatively
सर, अभी
positive.
समझा. मुझे लगा ये भी oscillatory होता है.
No, 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 no. I will tell you.
तो oscillatory क्या होता है?
Oscillatory, I can give you an idea. I will take an example. अभी right
Okay,
अगर
sir.
moment में
Okay, sir.
बताऊंगा. Oscillatory का मतलब है, don't suppose you take series this minus 1 की power n. Okay?
हाँ. हाँ.
If you take Sn, what will be? Minus
Zero.
1 plus 1 minus 1 plus 1. Just wait. Minus 1 की power n. चलो मैं इसको एग्जाम्पल ले लेता हूं. First I solve this example, then I will take the example of oscillatory. ठीक? Is it okay?
Okay, sir.
Okay. An, so here An is equal to 1 upon n plus 1. You can write, if you do by partial sum, you can do by another method also. This is not, I am writing because you can visualize easily. So my main aim is first find the Sn. This is A1, A2 plus An. This is 1 by 1 minus 1 by 2 plus 1 by 2 minus 1 by 3 plus this will be 1 by n minus 1 by n plus Sn. So if you take this Sn will be minus 1, this is cancel out first term. So I think this will be 1 minus 1 upon n plus 1. So here take limit n is tend to infinity Sn. Limit n is tend to infinity 1 minus 1 upon n plus 1. So this will be 0 and this is 1, which is a finite unique number. Whatever be the value of n, it means series An converges. Convergent and converges to 1. Now I am taking example 3 of oscillatory. Suppose you have a series n is equal to 1 to infinity minus 1n. Okay. Now check the convergence of this. So you have solution An is equal to minus 1n. So what is Sn? It will be like that: A1 minus 1 plus 1 minus 1 plus 1 up to plus minus 1 की power है. So here if you take n is even and odd, it give you different result. What you can say? Sn. If n is odd, what will be? N is odd, so it will give you minus 1, 1. If n is odd, if n is even.
सर
Is it-
n even में तो 0 आएगा ना?
Sorry, 0. Right. Minus 1 plus 1. So now if you take limit, this is minus 1 and 0. If n is odd or if n is even. So it means limit of Sn coming different and it depends upon the n. So it means this is series n is equal to 1 to infinity an is not convergent, or you can say oscillatory series. Is oscillatory series. So this is an example of oscillatory series. In previous two example, you can see it doesn't, whatever be the value of n. In second example, limit n is tend to infinity, Sn is coming 1. In first example, it is coming to plus infinity, whatever be the value of n. So this is the meaning of oscillatory series. I think there should not doubt is clear about the oscillatory series. Yes or no?
Yes, sir.
सर ये मतलब आपने जो एग्जांपल्स दिए वो समझ गया, बट जो डेफिनेशन है ऑसिलेटरी सीरीज का सर वो अभी भी मतलब क्लियर नहीं है. मतलब आपने जो एग्जांपल्स दिए ना वो सब समझा है, बट अभी ऑसिलेटरी सीरीज क्या है और क्या नहीं ऑसिलेटरी सीरीज है वो डिफरेंशिएट करने में दिक्कत हो रहा है.
आई एम टेलिंग यू, ऑक्सीलेटरी कह रहा है कि Sn जो लिमिट है, लिमिट एक यूनिक फाइनाइट नंबर होगा लेकिन यूनिक नहीं होगा. जैसे ही वैल्यू की n की वैल्यू चेंज होगी तो ये नंबर चेंज होगा. एज n इज टेंड टू इंफिनिटी तो ये एक नहीं होगा. कन्वर्जेंस में लिमिट इज ऑलवेज यूनिक.
हाँ,
तो ये है कन्वर्जेंस और ऑक्सीलेटरी में डिफरेंस में.
अच्छा,
और डाइवर्जेंस में क्या, फाइनाइट नहीं होगा, ये इंफिनिटी को कन्वर्ज करेगी, आइदर प्लस इंफिनिटी और माइनस इंफिनिटी.
ओके, अच्छा सर समझ गया. मतलब
Clear?
अगर वो
ये
एक डाइवर्जेंट
not.
ऑसिलेटरी सीरीज है तो
हाँ.
वो इंफिनिटी तक जाएगा, और अगर वो एक कन्वर्जेंट ऑसिलेटरी सीरीज है तो वो मतलब एक यूनिक सोल्यूशन नहीं देगा.
हाँ, क्या 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 बात अगेन स्पीक.
और अगर वो एक कन्वर्जेंट सीरीज है, कन्वर्जेंट ऑसिलेटरी सीरीज है
हाँ, वो
तो
फाइनाइट नंबर नहीं होगा.
हाँ हाँ
दो होंगे
दो
at
होंगे.
least.
हाँ ठीक है.
सर ऑसिलेटरी सीरीज कन्वर्जेंट भी हो सकती है.
कैसे होगी?
सर अभी
Not-
आरुष ने बोला ना.
नहीं, मैंने कहा फाइनाइट नंबर, नॉट यूनिक. नॉट.
ओके सर.
ओके, समटाइम्स आई यूज नॉट, वो साइलेंट मत होने दिया करो. ओके, नाउ आई मूव. तो दिस इज द, इन दिस वे यू कैन चेक कन्वर्जेंस और डाइवर्जेंस ऑफ ए गिवन सीरीज या ऑक्सीलेटरी with the help of Sn. Clear? Now there is a condition, necessary condition. Necessary condition for the convergence of series. It means, what is the meaning of, if a series is convergent, what is compulsory, what will be necessary? It means if a function is differentiable, necessary you can say this will be continuous. So it says, this is a theorem, if you have a series n is equal to 1 to infinity an converges, then limit n is tend to infinity an will be 0. If you have a convergent series and you take an, nth term an, and it will approach to 0 as n is tend to infinity. This is compulsory. Okay, converse of this theorem is not true. It means this is similar. If differentiable function is differentiable, it will be continuous, but converse is not true. To converge, if you are able to prove that this is not continuous, you can say function will not be differentiable. Same thing, if you are able to prove that an an does not approach to 0, you can say this series is not convergent. Okay. So here proof I am solution doing, and I will do some example solution. Let series n is equal to 1 to infinity is convergent, and suppose it converges to a number, suppose s. So what is Sn? A1 plus A2 plus An. You can write Sn minus 1. A1 plus A2 plus An minus 1. So subtract Sn minus Sn minus 1. Here this is An. So one more point I want to, so far we are dealing a series which have only positive terms, alternatively not negative and positive. So here Sn is equal to Sn minus 1, this is equal to An. Taking limit as n is tend to infinity both sides. So we have what we have, limit n is tend to infinity an. This will be limit n is tend to infinity Sn minus limit n is tend to infinity Sn minus 1. Akshay Agarwal. So this is, I think, s minus s. I told you n is tend to infinity, same thing, n minus 1. So this is 0. So I have done this proof. If this is a series converges, so this will converge to Sarthak Kapoor. Good morning, sir. It is my first day and I am unable to understand. Sarthak, are you hearing me? Sarthak Kapoor? He left. और लिखने से पहले ही चला गया क्या? अगर सार्थक कपूर आए तो प्लीज टेल मी. Right on the channel. He left. Okay.
Yes, sir.
तो दिस इज लिमिट n इज टेंड टू इंफिनिटी. और अगर आपका वो फ्रेंड हो तो उससे कह देना कि वो चलो he will write the mail to me. So this is the necessary condition of this. So there is actually, we have a benefit of necessary condition. If necessary condition does not hold, so you can say the series does not converges. You can say converse is not true. It means it is not necessary. It may be chance that limit n is tend to infinity, an is equal to 0, but series may or may not converge. Second, if you are able to prove that limit n is tend to infinity, n is not equal to 0, then you can say the series is diverges. So I am taking example of this type. Example 1. Simple example. Suppose you have series n is equal to 1 to infinity sine n. N is equal to 1 to infinity an. Check convergence of this. Here, question is same. Check convergence or divergence. If I am not writing, convergence or divergence, the question is same, check the convergence. So here, what is an? So before checking Sn, so what we do? We check an, because if it is convergent, so it must be 0. If you take limit sin n, what is it? This is a finite number lie between -1 and 1. So it does not oscillatory number, actually oscillatory value. This is oscillatory value. So what can you say by about, if it is not 0, so you can say limit n is tend to infinity, an is not equal to 0. So what can you say? Series n is equal to 1 to infinity, sin n diverges. It is not converges. One more example I am doing. So this necessary is useful to check whether convergence or divergence in this way. Now this is, I am taking one more series. N is equal to 1 to infinity log n plus 1 upon n. I have taken this example. Sorry. This is an. So here question is same. Here an is equal to log n plus 1 over n. Yeah, you can do log 1 plus 1 by n. Check. Limit n is tend to infinity. An. So this is limit n is tend to infinity log 1 plus 1 by n. So this will be log 1, which is 0. So here limit n is tend to infinity, an is equal to 0. But I have proved this series is diverges. In first example, this is diverges log n plus 1. So it means what I want to say, it is possible the limit n is tend to infinity 0, but series may or may not converge. But if it is convergent, then limit n is tend to n will be 0. But series n is equal to 1 to infinity log n plus 1 upon n diverges. So this is about necessary condition. If anybody has doubt, ask me. No.
Sir, in the second example, how are we able to say that it's divergent? We just proved that it's not convergent, right?
Normally, अगर आप converges नहीं है तो diverges लिख देते हैं. It is not convergent, it means it is divergent. अगर आप divergence में और particularly अगर आप निकाल पाओ, जैसे कुछ सीरीज ही होती हैं, अदरवाइज फिर आप लिख देते हैं ऑक्सीलेटरी. अदरवाइज नो नीड टू राइट ऑक्सीलेटरी. अगर आप एग्जाम में भी आता है, अगर वो ऑक्सीलेटरी है, अगर आप नहीं लिख पाते और यू राउट नॉन कन्वर्जेंट और डाइवर्जेंट, तो आपका ऐसा नहीं है क्वेश्चन गलत हो गया. हाफ मार्क्स कैन बी डिडक्टेड, इससे ज्यादा नहीं.
ओके सर.
Are you getting it? This is a particular type of divergence. Clear na? Oscillate.
Okay, sir. Okay.
I gave you the example of mango.
सर
Any doubt?
Sir?
Jatin? Yes.
यस सर सर जिसके हमने थ्योरम में लिखा कि ये जो है सीरीज ये कन्वर्जेंट है, तभी ये अपने पास आया कि लिमिट n टेंडिंग टू इन्फिनिटी an 0 होगा,
हाँ
है ना सर? ये इसके उल्टा यानी कन्वर्ज ट्रू नहीं है।
हाँ
तो सर जिसकी पहला एग्जांपल है, तो पहले एग्जांपल में अपन ने पहले इसको माना ना कि ये कन्वर्जेंट है, बाद में तो an
नहीं,
जो है
मैंने माना ही नहीं। मैंने कहा माना, मैंने तो चेक करा।
नहीं सर, जिसकी अपन ने चेक करा कि an है ना ये 0 के इक्वल नहीं है,
हाँ
फिर अपन ने बोल दिया कि ये डाइवर्जेस है, तो अभी तो आपने कहा कि कन्वर्ज ट्रू नहीं है।
मैंने कन्वर्स नहीं किया, आपको एग्जांपल देता हूँ डिफरेंशिएबिलिटी और कंटिन्यूटी का। अगर कोई फंक्शन, इफ ए फंक्शन इज डिफरेंशिएबल देन इट इज कंटिन्यूअस, कन्वर्स इज नॉट ट्रू। अगर किसी फंक्शन को आप कंटिन्यूअस नहीं है ये प्रूफ कर दो तो डिफरेंशिएबल
हाँ।
तो होगा ही नहीं।
हाँ नहीं होगा।
वही करा मैंने। कंटिन्यूटी लिमिट एन इज टेंड टू इन्फिनिटी an है और डिफरेंशिएबिलिटी आपकी कन्वर्जेंस है।
ओके सर, ओके क्लियर
Are you
हो।
getting it or not?
हाँ सर।
Any other, Vibor? So is it clear now? I tell you the a test that is known as the harmonic series sometimes, or in some books it is written as P series. Okay, it says this series, if you have a series like that, n is equal to 1 to infinity p raised to r, this converges if p is greater than 1 and diverges if p is less than equal to 1. This is a p series test. So remember, suppose you have a series in the ratio of 1 upon n की power p, it converges if p is greater than 1 and diverges p is less than 1. Now I am doing one more example before doing next theorem. This example you see everywhere and you might study it in your intermediate also. Geometric series. I am giving the complete structure of this series. Suppose you have this series, n is equal to 1 to infinity x raised to power r. Sorry, r minus 1 ले लीजिए या sorry, this you can write n minus 1 like that, or don't confuse, I am discussing this 1 plus x square, this is infinity gp, all terms are positive. Now it says this series, you can write, you may have little bit confused, yeah, you can write in this way. This series n is equal to 1 to infinity an first is, this converges if this mod x is less than 1. Second, what it says, it diverges if this x is greater than 1. And third is diverges, sometimes it is written diverges mod x is greater than 1. It is also written, the only two cases. If you want to write 3 cases, oscillates, because some students are having confusion. oscillate if x is less than. So I will show when it is oscillate. In some books, it is written diverges for this and diverges for this. -1, it is also written this is diverges. No need to write oscillate. But I am giving explicitly so that you can understand better way. So first, what is Sn? I am doing for this less than 1. Sn is equal to 1 plus x plus x की power, you can write n minus 1. Or here Sn, here you can take Sn plus 1 also. There should not be confusion. If limit n is tend to Sn s, so you can write limit n is tend to infinity Sn plus 1 also. So here I am doing from this, so this will be 1 minus x की power n over 1 minus x. What is limit? Sn, this is less than 1, so this will be 0. So limit n is tend to infinity 1 minus xn over 1 minus x, 1 upon 1 minus finite unique number. So so it means this series, whatever this series, n is equal to 1 to infinity an converges. Case second, if x is equal to 1. If x is equal to 1, what will be your series? N is equal to 1, you can write directly n, Sn. What will be an? An will be 1 because all terms of this series will be 1, 1, 1, 1, 1. So an is equal to 1. Apply limit n is tend to infinity an, which is 1 not equal to 0. So by necessary condition, you can say there are other way also. By necessary condition, you can say series n is equal to 1 to infinity an diverges. Now, if x is greater than 1, okay? If x is greater than 1, again you check an. An will be r raised to power n minus 1. Limit n is tend to infinity an, r is greater than, so it will be infinity. This is infinity not equal to 0. Again by necessary condition. Series n is equal to 1 to infinity an diverges. The two cases I have done. Now case third. In case third, you can see these things. Case third, let us see what is case third. Oscillate if x is less than equal to -1. If
सर केस सेकंड में ये an is equals to r के बजाय x आएगा ना?
कहीं मैंने ओ सॉरी x, ये x ही x, this is x, this is same. Okay, if x is equal to -1, so what will be an? If x is equal to 1, so what will be -1 and 1? If -1 will be if n is, I think, even, because x की power n minus 1. If n is odd, so if you take limit n is tend to infinity an, so this is coming -1, 1. if n is even or if n is odd. So in both cases, this is not coming zero, oscillate, and it is oscillatory. So you can say not convert, not divergent, or more precisely, you can say because two value are coming, oscillates, or you can say diverges. Complete answer is this. Now, if x is less than -1, so what I say, I am doing x is equal to minus, you can write rho, where rho is positive. You can write if you have any number negative. So here, what I am doing, take Sn. If rho is less than 1, so can I write what will be? Xn will be -1 की power n or rho n, like that. So Sn, what will be 1 plus x square up to plus xn -1. So it will be, I think, greater than 1. So I think minus rho, so it will be modulus is greater than 1. So I think, please check, am I right or not? -1, and this will be minus rho -1. If mod x is greater than 1, so x की power n -1 upon x की power n. GP, sum of the GP. Am I right or not?
Yes, sir.
Yes, sir.
If you take limit n is tend to infinity Sn, limit n is tend to infinity -1 n rho n -1 minus rho -1. So what will be the answer? Rho is positive. This is positive. Sorry, rho is greater than 1. So if you take 1 is tend to infinity, when rho is greater than 1, so this will approach to infinity. Rho n. If this is infinity, so there will be two cases. If n is odd, if n is odd, so this is infinity, so this will be minus infinity. It doesn't make difference. Minus positive, so this will be plus infinity. If n is even, this is infinity plus even, this is plus infinity, but minus because this will be minus infinity. So again you can say no limit n is tend to infinity, Sn is not coming 0 or approaches to infinity plus. Sometimes it is approaching plus infinity, sometimes it is approaching minus infinity. So normally you can say this series n is equal to 1 infinity an diverges, but it diverges sometimes plus infinity minus. So, or you can say it oscillates. Is it clear? If anybody has doubt, I am right in a nice way. This is plus infinity if n is what coming odd. Minus infinity if. So if anybody has doubt in this, can ask me. So you can
Sir, सर ये जो सर नेसेसरी कंडीशन में सर अगर लिमिट ए नॉट इक्वल टू 0 आ जाए तो सर मतलब अब आगे सर ऑसिलेटरी है कि नहीं है, इसे चेक करने के लिए सर मतलब मिनिमम 2 वैल्यू पर चेक कर लें कि अगर अलग अलग वैल्यू आ रहा है तो
अगर आप अलग अलग दिखा दें तो यू कैन सो नो डाउट। या वैसे जब भी आप an करोगे ना, अगर ऑक्सीलेटरी होगी तो nth टर्म के उसमें कुछ संबंध आएगा, then you can choose n is even and odd.
Okay sir.
Any other?
सर सार्थक कपूर आ गया ना,
हैं?
वो
What are you
सार्थक
saying?
सार्थक कपूर आ गया ना सर, वो जिसने
Sarthak
चैट
Kapoor.
में
Okay, thank you. Sarthak, first I want to stop this report.